All right, so in assignment number 9, we started solving logarithmic equations, and we did that by changing the logarithmic, we did exponential equations, and we did the exponential equations by using logarithms. Today we're going to be solving logarithmic equations, and so the way we're going to solve logarithmic equations is by converting them into exponential form. So let's go ahead and get started. Here we have our first logarithmic equation. We want to figure out what is the value of x here that makes the left-hand side equal to 5. And so we know that the base, because this is a common logarithm, the base here is 10. So I'm going to go ahead and rewrite this whole logarithm function in exponential form. So it's going to look like this. It's going to be 10 to the 5th power is equal to 3x plus 1. Well, 10 to the 5th power is 100,000, and that equals 3x plus 1. So then I'm just going to solve this for x. I'll subtract 1 from both sides, and I'll get 99,999, and that equals 3x. So when I divide by 3, I'll have x equals 33,333. And so if you were able to stick 33,333 in for this x here, multiply it times 3, add 1, take the log of that, you should get 5. Let's try a similar problem. Still a common logarithm, which means the base is 10. So I'm going to take 10 to the negative 1st power, and that's going to give me 7x, or 7 minus 2x. So we have 10 to the negative 1st is equal to 7 minus 2x. Well, 10 to the negative 1st power is 1/10, or 0.1, and that equals 7 minus 2x. And so I'm going to go ahead and subtract 7 from both sides. So we have the 0.1 minus 7, which is negative 6.9, and that's going to equal negative 2x. So then when I divide both sides by negative 2, I'm going to have that x here is equal to 3.45. So if you were able to stick 3.45 in here for this x, we would have 7 minus 2 times 3.45. We take the log of that, we would get negative 1. Let's try another example here. Here we have two logarithms, and so we can't solve this. We can't put it in exponential form when there are two logarithms. And so what we're going to have to do is write this as a single logarithm. And so we're going to use our properties for this. I'm going to start by moving this 2 out in front here and writing it as x squared. And then because I'm subtracting here, I can write this as a single logarithm by going the log of x squared over 3 equals 2. And so now it is a common logarithm. Again, there is no base, which means the base is 10. So that means I'm going to have 10 squared, if I put it in exponential form, is going to equal x squared divided by 3. So I know that 10 squared is 100. So 100 equals x squared over 3. Multiply both sides by 3, and I'll have 300 equals x squared. And so then I want to undo the square part, so I'm going to take the square root of both sides, and I'll have that x is equal to, I could say it's the square root of 300, but we probably want to simplify that. We know that 100 goes into 300. It's 100 times 3. So I could take the square root of 100 times the square root of 3 to get the square root of 300. But we know that the square root of 100 is 10, radical 3 then. And so the final answer for number 3 is that x equals 10 radical 3. Let's try one more question here. Number 4, and I would encourage you to pause the video and see if you can do this one on your own, and then you can start it back up and see if you got it right. So I'm going to first write this as a single logarithm by taking the log of 6 over 3x. Because I'm subtracting here, I can divide the 6 and the 3x, and that's equal to negative 2. Well, I could simplify 6 over 3x. I could write it as the log of 2 over x equals negative 2. Because 6 over 3 is the same thing as 2 over 1. Well, it's common logarithm, so the base is 10. So that means 10 to the negative second power is equal to 2 over x. So I want to get this, that's a 2 there. I'm going to get this x in the numerator. I'm going to multiply both sides by x. So we have x times 10 to the negative second power is equal to, that's negative second power there, is equal to 2, because these x's canceled out. Then I'm going to divide both sides by 10 to the negative second power. This is 10 to the negative second power. So these will cancel, and I will have x equals 2 over 10 to the negative second. Now I could write this as 2 times 10 to the positive second, because we know that to make an exponent positive, we would put it on the top if it's already on the bottom. We know that 10 squared is 100, and 100 times 2 is 200. So in this case, x is 200. And that's what we're going to be doing on our homework assignment for tonight, solving logarithmic equations. You have to remember that whenever you solve a logarithmic equation, you're going to have to, at some point, put it in exponential form. We'll talk to you more tomorrow.